Hello, class. This is Pre-Algebra, Chapter 4, Lesson 1, 4.1, Variable Equations. Today we're talking about variables and their equations. Today is all about one concept, and that is balance. When we think about balance, we might think about balancing on a skateboard or on a high beam, sometimes even a seesaw. We don't see those too often anymore. But the basic idea is to achieve perfect balance. Whatever is on one side must also be on the other. In math, if we're talking about weights, the weight that is on one side of the balance board, let's say there's 1 pound here, to balance it out on the other, you must also have 1 pound there. We represent this idea with the equal sign. We say 1 pound is equal to 1 pound. Now, this might seem like an obvious statement, but this is the basics of what we are talking about. Equality, balance. If I add another pound to this side, well, don't I tip the balance to the left? Now I have 2 pounds. And the only way to reestablish balance is to add another pound to this side. And so we have achieved equal balance yet again. When we are talking about variable equations, the same thing is going on. We are trying to balance each side of the equal sign or each side of the equation. So for example, if I were to tell you, let's imagine that this line represents the equal side, right? Whatever is on the left side must equal whatever is on the right side. So if I tell you that the variable x, remember variables stand in place of values, is equal to, let's say, 10. Well, to keep this balanced, to keep this situation, this equation balanced, I must understand that whatever's on this side must also be on the other side. So x must also equal 10. So in the reality, 10 is equal to 10. And I would say, well, for this to be true, x must be 10 as well. It doesn't make any sense to say x is 11 because therefore it could not be the case that x is equal or to 10. 11 does not equal 10. So that can't be true. For this equation to be true, it must be the case that x is 10 so that both sides of the equation can be balanced. Let's try it again with a different one. There's not much math going on here, actually. If I told you that y is equal to 17, well, then you know, based on this, that y, no matter what this is, has to equal 17. So what are some things y could be? Well, most obviously, y could in fact be 17, because 17 equals 17. It could also be 16 plus 1. Well, why could y be 16 plus 1? Well, because 16 plus 1 is 17, and 17 equals 17. It could also be 20 minus 3. And 20 minus 3 equals 17 because it is true that 20 subtracted, take away 3 is 17. And so y has the ability in this situation to be either 17, 16 plus 1, 20 minus 3, or any other set of numbers and operations that gives you the answer 17. And that's how you find balanced equations. Now, let's get a little bit tougher. Let's say I give you an equation like this. I tell you that some number s minus 3 equals to 2. Well, as you know, right, the answer to this is probably going to be 5, because you just know math, right? 5 minus 3 is equal to 2. Okay? But let's say we didn't know that. What the book is going to ask you is, well, first what they're going to do is they're going to give you a value for s. They're going to say, look, here's the number 7. If s is equal to 7, is it true that s minus 3 equals 2? So they're asking yes or no. For this situation, s could be 7. How do I test this? Well, all I need to do is take this s and replace it with what they told me it was. And what they told me the s was is 7. And so I say 7 minus 3. Does that equal 2? Well, 7 minus 3 is 4. And then I ask myself, does 4 equal 2? Well, no, it does not. These things are not balanced. They are not equal. The left side is not equal to the right side. Therefore, the answer is no. S cannot be 7 here. Now, let's say s equaled something else. Let's say they told me that s was equal to 5. Now I'm going to see if this is true. If s is equal to 5, does s minus 3 equal 2 work? Well, I replace the s with what they told me s is going to be, which is 5. And I say 5 minus 3, what does that equal? Well, 5 minus 3 is in fact 2. Does 2 equal 2? Yes, it does. Both sides are balanced. They are exactly the same. Therefore, s could be 5. Let me ask you this. Could s be 2 plus 3? Could s be 2 plus 3 for the equation s minus 3 equals 2? Yes or no? Well, all I need to do is replace s with what they said s is, and s is 2 plus 3. So I write 2 plus 3. I put that in parentheses to know that I'm just dealing with that right now. And then I rewrite the whole equation, minus 3 equals 2. And then I say to myself, all right, what is, according to PEMDAS, the order of operations, let's remove the parentheses first. Parentheses says 2 plus 3. 2 plus 3 is in fact 5. Oh, look at that. Then do I have any exponents? No. Any multiplication? No. Any division? No. Any addition? No. Subtraction is the last thing I have. 5 minus 3, does that equal 2? Yes, it does. 5 minus 3 equals 2. 2 equals 2. Therefore, yes. S could be 2 plus 3. For this situation, s minus 3 equals 2. Remember, as long as it comes out true on both sides and balanced, it will work. Let's try some other equations like this. Let's say they gave you is 2 a solution of the equation 5 plus 3 times y equals 12. So what are they asking me here? They're asking, if I substitute 2 for my variable y, will I get 12 on both sides? How do I test that? Well, first step, I rewrite the equation. And then I must understand what this equation says. This equation literally says 5 plus 3 times whatever y is Will that equal 12? Well, I'm going to substitute my missing variable. Oh, this is 3. The y is going to be the 2, because that's what they're asking for. Is it a solution? They're asking if I replace my variable with this number 2, will it give me 12? Let's do PEMDAS. PEMDAS says, I start with my parentheses first. Do I have parentheses? Yes, I do. I have the 3 times the 2 here. 3 times 2 is 6. I rewrite my equation to clean it up. 5 plus 6, does that equal 12? Well, 5 plus 6, I don't have exponents, I don't have multiplication, I don't have division, I do have addition. 5 plus 6 is 11. Does 11 equal 12? Are both sides balanced? No, they are not. So the answer to this is to a solution of 5 plus 3 times y equals 12. The answer is a big fat no. And why? Because these two are not balanced. Let's try one more. Oh, let's try, here's a good one. Sometimes they'll write the question like this. Here's the number that we want you to test in front of the semicolon. We want you to test this number inside this equation. 4 times x plus 1 equals 16. That's the original equation. What I'm going to do is I'm going to replace the x with a color-coded x, so you know what we're going to substitute. The question is, if you place 3 into this spot for x, will the equation turn out to be 16? The answer is going to either be yes or no. Is 3 a solution? So how do I solve this? Well, first I rewrite the equation. 4 times x plus 1 equals 16. Next, I substitute my test variable for my test value for my variable. So it's going to be 4 times whatever 3 plus 1 is. Some of you can already see the answer here. I'm going to now consult PEMDAS. And I'm going to say, all right, let's do parentheses first. In my parentheses, I have a 3 plus a 1. That's going to be a 4. So I'm going to have 4 times 4. Does that equal 16? And some of you can already see that it is what the case is. I don't have exponents. I do have multiplication. 4 times 4 is 16. Does 16 equal 16? Yes, ma'am. Yes, sir, it does. So, is 3 a solution for the situation 4 times x plus 1 equals 16? The answer is yes. And that's how you solve variable equations. If they give you what the variable should be. Now, I know it doesn't say x equals 3. When I write the problems for you in your homework, it will say, here is what x or y or b or c equals. When you substitute it into the equation I give you, does it come out to be this answer on the other side of the equal sign? Now, I need you to understand that doesn't always have to be in this format. Sometimes it might look like this. For the equation, and then the answer might be on this side. 10 equals x divided by 2. And then it will give you the semicolon, and then it will give you a number to test. Is 20 a solution? Yes or no? All right, so what do I do? First, I rewrite the equation. 10 equals x divided by 2. Then I substitute in the test value. And where do I substitute it in? For the variable. 10. Does that equal 20 divided by 2? Well, what is 20 divided by 2? 20 divided by 2, 2 goes into 2 once. 1 times 2 is 2. 2 minus 2 is 0. How many times does 2 go into 0? No times. 0 times 0 is 0. 0 minus 0 is 0. 10. I get 20 divided by 2 is 10. Does 10 equal 10? Yes, sir. Yes, ma'am, it does. So 20 is a solution for the equation 10 equals x divided by 2. The answer is yes. And there you go. That's how you solve, or that's how you look for solutions for variable equations.